Hi students, this is Mr. Yao. In this lesson, we are going to talk about 4.19c, where we will learn how to write piecewise functions. So now we're going backwards. Before we have learned if you are given the function, you are graphing it. This time you are giving the graph and you're trying to write the function. Here are the steps. Step 1, decide how many pieces the graph has and write the domain for each piece of the function. Clearly you can see there are 1 and 2 different pieces. F of x equals, I'm going to need to have 2 different functions. For the one on the top left, that one domain is all the way from the left side to -2. So x is less than -2. And you could see this is an open circle, so that is why I'm going to have less than -2, doesn't have an equal sign. Then the other one starting from -2 going all the way to the right, so x is greater or equal to -2. When you're writing the domain, 2 things to pay attention. One, pay attention to open circle or closed circle, and the other one is the domain are only about the x values. So whatever point you see, you're going to need to drop it down to the x axis so you can find numbers on the x-axis. Now, for each function, for each domain, we are going to write the corresponding function. The functions could be constant function, or linear function, or quadratic function. First one is this one. I'm going to extend it so I can see exactly where the y-intercept is. The y-intercept is actually at 5. And you can see the slope is 1 up, 1 over, so it's got to be x plus 5. Now for the other one, it's a flat line. So this flat line is at 2. That is going to be a constant function. So that's going to be 2 for the second function. So that's the example with steps. Now let's see more examples. Example 1, I have 3 different pieces, so f of x equals, let's start writing the domain. First one on the bottom left is going to start from -infinity to right here, -2. So x is less than -2 also because that's an open circle. And the second one, it starts from -2. So -2 is less than or equal to x all the way to the right to 2. So it's at less than 2 because on the 2 side, it is an open circle. There isn't an equal sign. Now the other one I'm going to have right here. That one actually doesn't start from 2. No one said the graph has to be all connected. Everything needs to be covered. We can totally have a break in the middle. This is actually at 3, so x is greater or equal to 3. Now let's write the function. First one, if I extend it, let's pretend it's actually going like well, actually, it's right here. So it's going to be 1, 2, 3, 4, 5 up, 3 over. So the slope is going to be 5 up, 3 over, 5/3 x. If I extend it, it's 1, 2, 3, 4, 5, 1, 2, 3. That's my actual next point. So this is going to be a bit tricky, but we actually want to find out where it crosses the y-axis. So if we follow that, clearly you could see is only going to the right by 2. If when it's 3 to the right is 5 up, then when it's actually 2 right, I'm basically doing 5/3 times 2, which is going to be 10/3, but 10/3 on top of this, which is 2, so 10/3 plus 2 is going to be 16/3. That is a y-intercept. So this is something that's not quite related to this lesson, so you can try to figure that out in the future. But we're not going to add any question like that for the assignment. So let's have a look at the other 2 functions. The second function is a flat line at 1, 2, 3, at 4. So it's going to be 4. And the third function, I can extend this one. That is actually down 2 over 1, down 2 over 1. So if I extend back, left one up 2, left one up 2, and left one up 2 is going to be a point up. Slightly outside the graph, 1, 2, 3, 4, 5, 6, 7 at 7. And the slope is down 2 over 1, so that is going to be -2x plus 7. There's my function for example 1. Next, example 2. 3 pieces. Let's write the domain first. First one all the way from the left until right here, -1. So x is less than or equal to -1. That is a solid dot. The second one is actually from -1 to 1. And this time there's no closed circle, so it's -1 less than x less than 1. My third function is going to be starting right here at 1. So x is greater or equal to 1. That is my third function. I mean the domain for the third function. Now let's write the function for the bottom left. I'm going to extend it. This is actually at 2 as the y-intercept. So it's going to be x plus 2. Because that is 1 up, 1 over. So the slope is 1. For the second function, the slope is also 1, but this time the y-intercept is at 3. So it's x plus 3. And the last function, if I extend it back, the intercept is actually at 1. The slope is still 1, so it's x plus 1. That is my third function. Next, example 3. This time you can see the lines are connected. Well, this is a special function. This is actually an absolute. Well, I actually spelled that wrong. There's no O right here. Absolute value function, which is the check mark shape of function. So you can choose to write this right away because that is 1 up, 2 over. So basically my slope is 1/2, and this is an absolute value, so it's 1/2 of absolute value of x. That is if you just write it as an absolute value function, but we are still going to try to write it as piecewise function because it does have two different pieces. So f of x equals, let's write the domain first. The endpoint is actually on the y-axis, so it's actually at 0. X is less than 0, x is greater or equal to 0. This is not the only way to write it. You can also choose to write it as x is less than or equal to 0 and x is greater than 0. Either way, here is the only thing. You can't have equal on both zeros. Even though the graph is connected, there's no breaking point. You can't have both of them equal 0. That's kind of that's not how piecewise function works. The domain shouldn't be overlapping. So only as long as only one of them has an equal sign, you can write it either way. The left side is going to be a slope that's negative because it's 1 down, then 2 right. So it's going to be negative 1/2 as the slope and x. The y-intercept is 0, so we don't need to write it. As for the right side is 1 up, 2 over is a positive slope. So it's just going to be 1/2 times x. If you look at the absolute value function, well, that's kind of how it works. We basically took the absolute value away and give it to a negative one and a positive one. The 1/2 is still in the front. So that's example 3. Example 4. F of x. This is not a check mark, so this is actually not an absolute value. It's just two linear functions that are connected. You can still see the breaking point is right in the middle. So I can have an equal for the first function, and that means I can't have an equal sign for the domain for the second function. If you write the first function, the slope is 1 up, 1 over, 1 up, 1 over, so it's just x. And it's actually, the y-intercept is 0, so it's just x. For the second function, that is going to be 2 up, 1 over, 2 up, 1 over, so my slope is 2, and the y-intercept is still 0, so it's just a 2x. That is example 4. Next, example 5. Example 5 is right here. F of x. I'm going to have 3 different pieces. First one is to the left of my my y-axis, so it's going to be x less than 0 because there's an open circle. Then the function is actually just this point on the y-axis. That means that domain is actually just 0 because that's a solid point. And then the top function is actually everything to the right, so x is greater than 0 because it is an open circle. Now these are all flat, basically flat lines. Even the dot is just a very short flat line. So that means they are constant functions. For the first function, the lowest one, the point to the left, that is at -1. The point is at 0, and the one on the top is at 1. That is the function for example 5. Next, example 6. F of x, start with the domain. First domain start at -4, so -4 is less than or equal to x. Stops at -2. I'm using all closed circle because these are two solid dots. And next, the next one starts at -2, is less than x, stops at 2, so less than 2. They're both open circle, so I don't have an equal sign in my domain. And the last one is right here at 2. Is less than or equal to x, which is less than or equal to 4, because these are both solid points. These functions are flat lines again, so I'm going to treat them as a constant function. Top is at 4, the middle one is at 2, and the lowest one is at -3. That is my piecewise function for example 6. Next, example 7. This one we do need a bit more information. Let's actually pretend this 1, 0 point is the vertex. So f of x equals domain. First one is stops at 1, so x is less than 1. Then my second function, because of the solid dot, is going to be x is greater than or equal to 1. My top function, which is the linear one, has a slope of 1. Let's actually pretend they're all on the intersection. So the slope is going to be 1, and the y-intercept is at 3. My second function, well, if we say this is the vertex, what we can check, it is just 1 right, 1 up, 2 right, 4 up. So it is a standard parabola just being moved to the right. Remember, so a then x minus h squared plus k. This is the part where it actually moved to the right. Since it moved to the right by 1, so it's got to be x minus 1 then squared. There's no up or down, so we don't have the k. There's also no stretch or shrinking, so there's no a in the front. That is example 7. Next, example 8. Start with the domain. There are 3 pieces. Just these, that point is actually connected. So the red piece and the blue piece, they're connected. The domain for the red one start from -5. So -5 is less than or equal to x, which is less than or equal to -2. At -2, I can include that in the red graph or the blue graph. I can include it in either one. Next, the blue one is starting from -2. Since I already included it here, I can't include it again, so it's less than x, which is less than or equal to right here at 1. And lastly, the green one, that is going to start at 2, but it's an open circle, so 2 is less than x. Then it stops at 5, which is a closed circle, so less than or equal to 5. Now let's write each function. The red one is just a flat line on the x-axis, so that is just 0. Next, the function, the parabola, that you can see is facing down, which means I do have a, that is basically the negative sign, x minus h squared plus k. I don't have an h because I didn't move left or right. You can see the vertex is still on the y-axis. The k, however, that is being moved 1, 2, 3, 4 up. So of course I have a plus 4 on the end. So here's my function, negative x squared plus 4. That actually is the middle function, which is actually blue. Let me change the color on that. So negative x squared plus 4. Lastly, the green one, that is, if I extend it, I can see the y-intercept is at 3, and the slope is down 1 over 1, so it's negative x. And negative x plus 3 is my third function. That is example 8. Next, example 9. 3 pieces again. F of x equals, first one all the way from the left until -2. So x is less than -2. Second piece, start from -2. It's a solid dot, so less than or equal to x. Then it stops at 1, so less than 1. If you haven't noticed, the middle function is actually the same as the previous example. Well, similar to the example. It's just now the y-intercept is at 5. So I can easily write that one to be negative x squared plus 5. No moving left or right, just facing down, so it's a negative sign in the front. And the vertex is being moved up by 5, so it's a plus 5 on the end. Now let me keep writing the domain for the last one. The last one started at 1, solid dot right here, so x1 is less than or equal to x, or I can write it as x is greater or equal to 1. You can flip all the inequalities, that's fine, as long as you have them and you're not messing up with the signs. Now here are the functions. The first one, I'm going to extend the line, is going to be at -3 for the y-intercept. The slope is down 1 over 1, so negative x plus 3. And the last function is going to be a parabola again, but this time it's facing up. 1 right, 1 up, that's fine. 2 right, 4 up, so it is still a standard parabola. The only thing that's happening is the graph is being moved to the right by 2, and then being moved down by 2. So if you remember the cheerleader effect, this h part is going to always be the opposite number. So if I move to the right by 2, it's going to be a minus 2. And if I move down by 2, that is still going to be a minus 2. So the function is going to be x minus 2 squared, the minus 2 on the end. Remember, horizontally is always the opposite. If you are moving to the right, intuition-wise, you feel like that's a positive 2. But it's always the opposite, so it's going to be a minus 2 inside the parentheses. That is example 9. Now lastly, example 10. F of x, let's start with the domain, starting from all the way on the left until right here, -1, with a solid dot. So x is less than or equal to -1. And my other functions start at 1, going all the way up. So x is greater than 1. For this one, there's actually not enough information. But just for practice purpose, since we're dealing with parabola, let's pretend this is your vertex, and then we'll deal with it that way. For the flat line, the constant function, it is at 2, so that is just going to be 2. For the parabola, however, it's going to be a bit different. 1 to the right, but this time it's not just 1 up, it's actually 3 up. And then 2 to the right, clearly there are way more. I don't exactly know the number. That's why I'm saying we don't clearly know what function it is. We are just pretending it is a quadratic graph. So at least for the first little part, it's not 1 right, 1 up, is 1 right, 3 up. So you can think it as a 3 as the stretching. My graph is being moved to the right by 1 and up by 1. Right by 1 is going to be an x minus 1, and then this up 1 is going to be a plus 1 on the end. So x minus 1 being squared, and then plus 1 on the end. Again, because it's moving to the right, but horizontally is always the opposite, so it's got to be a minus 1 inside the parentheses. So that is everything for 4.19c. Thank you.